Hi, in this video, I will be showing you problem number 4 of chapter 14, section 6. Find the directional derivative of f at the given point in the direction indicated by the angle theta. F of xy equal to xy cube minus x square at the point 1, 2 with an angle theta equal to pi by 3. So we're asked to find the directional derivative, and the direction of the angle of the direction is also given. The point is given, the function is given to us. So let's see what we mean by the directional derivative. The directional derivative involves, in order to know the directional derivative, it actually gives us the slope of the tangent to the surface in any direction. Like partial derivatives, f sub x and f sub y give the slope of the tangent in the direction of x and y axis. Specifically here, we can actually find out the slope of the tangent to the surface at the curve of intersection along any direction. That is what the directional derivative means. So in order to define directional derivative, we need to know what we mean by the gradient vector. So define the gradient vector del f for a function f of 2 or 3 variables. If f is a function of 2 variables, then del f, it's also called nebula, the Greek letter nebula, f, delta f, del f xy equal to fx, fy, the components fx and fy in the vector component form, which is partial derivative of f with respect to xi plus partial derivative of f with respect to yj. This is for two-dimensional. For a vector f of 3 variables, del f or nebula f or gradient f of xyz equal to, in the component form, fx, fy, fz, all at the point xyz. This can be written in the ijk form as partial derivative of f with respect to xi plus partial derivative of f with respect to yj plus partial derivative of f with respect to zk. So this is what the definition of the gradient vector is. Now what is the directional derivative? Express duf, which is called the directional derivative of the function f, in terms of the gradient vector del f, where u is a unit vector with the components a, b. Du of f of xy is del f xy dot u, unit vector u. So it's a dot product. It's for two-dimensional. It's three-dimensional. It is del f at xyz dot product with the unit vector u. So unit vector u gives the direction. Del f is the gradient vector. So in our problem, we are asked to get the directional derivative. So let's write down what are given in the problem. F of xy is xy cube minus x square. So del f has components, the partial derivatives fx and fy, which is f of x equal to y cube minus 2x. So when you do partial derivative with respect to x, you keep y as a constant. When you do partial derivative with respect to y, you keep x as a constant. So fy equal to 3xy square, you're going to keep x as a constant and differentiate with respect to y. So it is 3xy square, and derivative of x square would be 0 because it's a constant after all. So del f should be written as vector del f. Vector del f, which is the gradient vector, is f of x, f sub x I plus f y j, f sub y j equal to y cube minus 2x I plus 3x y square j. So that is a gradient vector. Now del f at 1 comma 2 in this problem. So substitute x equal to 1 and y equal to 2 in this previous step. So we get 8 minus 2 times I plus 3 times 1 times 4 j, which becomes 6i plus 12j. So that's how we got the gradient vector at the point 1 comma 2. Now the directional derivative is needed in the direction of q, which is theta, which is equal to pi by 3. So directional derivative is needed in the direction of theta equal to pi by 3. So we need to find out the unit vector in the direction of pi by 3. So unit vector is a vector of length 1. So if you consider the vector, so if this is r, this is equal to the vector v whose magnitude is, let's say, r, then the horizontal component is going to be r cosine of theta, and the vertical component is going to be r sine theta. So if we know the magnitude of the vector, by looking at the horizontal and vertical components, we can write the vector. So here theta is pi by 3 and r equal to 1 because it is of unit vector, so length is 1. So the vector, unit vector, can be considered as 1 cosine pi by 3 for the horizontal component, 1 sine pi by 3 for the vertical component. So it is theta equal to pi by 3 at the point 1, 2. So unit vector u is given by, in the direction of theta equal to pi by 3, can be written as r cosine theta I plus r sine theta j, where theta equal to pi by 3 or theta equal to pi by 3 and r equal to 1. So u equal to cosine of pi by 3 I plus sine of pi by 3 j, which is 1 half I plus root 3 over 2 j. In 1 we got del f at 1, 2. In 2 we got the unit vector u. So all we need to do is to get the dot product of these two, 1 and 2, to get the directional derivative in the direction given by the angle theta equal to pi by 3. So du f, which is the directional derivative at 1, 2, is del f at 1, 2 dot unit vector u, which is 6i plus 12j dot product with a half of I plus root 3 over 2j. If you do the dot product of these two, you have to multiply the corresponding components and add. So which is 6 times 1 half plus 12 times root 3 over 2, which is 3 plus 6 root 3. That is the directional derivative. Hope this video helps.